Hey everyone, and welcome back. Today we are jumping into this ultimate study guide explainer, where we're going to bridge that gap between abstract textbook chemistry and the actual real-world reactions happening right now in your own home kitchen. I am super excited to be your professor today as we decode the hidden language of the substances all around us. For you first-year science students, we're going to take these foundational concepts and make them crystal clear, super visual, and honestly, impossible to forget. Let's get into it. Here's a quick look at our syllabus for today's masterclass. We'll start with the acid and base basics, move into chemical reactions in action, break down the pH scale, explore indicators, look at salts beyond the table, and wrap it all up with exam prep and flashcards. All right, Section 1, the acid and base basics. Okay, so as first-year science students, you absolutely need to grasp the Arrhenius definition. The crucial takeaway here is that we classify these substances entirely by how they behave when we dissolve them in water, right? It's not about what a chemical is in total isolation, it's all about what it does the second it interacts with an aqueous environment. This breakdown brilliantly illustrates the direct contrasts between the two. Acids, think of the lemon juice in your fridge, taste sour, turn blue litmus paper red, and most importantly, they release H+ ions in water. But hey, remember proper safety and handling procedures here, because many lab acids are highly corrosive. Bases, on the flip side, are the complete opposite. Think of household soap. They taste bitter, they feel soapy or kind of slippery to the touch, they turn red litmus paper blue, and they release OH- ions. If you can just memorize these opposing traits, you have literally unlocked the core of aqueous chemistry. Moving right along to Section 2, chemical reactions in action. Notice the absolute consistency of this rule. Whether you're working with an acid or a base, reacting it with an active metal is always going to produce a salt and release hydrogen gas. Just imagine dropping a piece of active metal into an acidic solution. You know those bubbling, fizzing reactions you always picture in a chemistry lab? Well, that is literally the hydrogen gas escaping right before your eyes. But what happens when our two main subjects face off against each other? When acids and bases react together, they completely cancel each other out in what we call a neutralization reaction. They combine to form a brand new salt plus water. And this isn't just some textbook theory, it's happening in your own body. When you take a basic antacid for an upset, highly acidic stomach, you're actually performing a neutralization reaction inside yourself to find some relief. How cool is that? Now, for your exams, you absolutely must remember this specific reaction. Acids react with metal carbonates to release carbon dioxide. But how do we actually prove it's carbon dioxide? Well, we use a definitive visual test. When that invisible gas is passed through lime water, it turns the clear liquid distinctly milky. It is a perfect, undeniable visual confirmation. You can't miss it. Section 3. The pH scale explained. You know, the pH scale might look like just a simple ruler with a set of numbers, but the crucial point is that it's actually a highly precise measurement of hydrogen ion concentration. It tells us exactly how aggressive or how mild our aqueous solution truly is. To really anchor this in your mind, think about the extremes. The strongest acids are down near zero, like the incredibly corrosive battery acid in your car. Pure, neutral water sits dead center at a perfect 7. And then strong bases, like that heavy-duty bleach sitting in your laundry room, push all the way up toward 14. The further you get from 7 in either direction, the more intense the chemical becomes. On to Section 4, indicators, seeing and smelling. Visual indicators are critical for your lab notes. Phenolphthalein is a classic example. It remains completely colorless in an acid, but the second it hits a basic environment, bam, it turns a vibrant, unmistakable pink. Meanwhile, methyl orange flips from red in an acidic solution to yellow in a basic one. These give us immediate visual proof of an environment's pH without us having to do anything dangerous. But interestingly, we don't just use our eyes in chemistry. We can actually use olfactory indicators to literally smell the difference between chemical states. That's right, we are detecting pH changes using our noses. Everyday substances right out of your pantry, like vanilla extract or a chopped onion, act as brilliant olfactory indicators. They'll keep their strong, recognizable scents when submerged in an acid. But if you drop them into a base, their smell completely disappears. It's kind of like a magic parlor trick, but it's actually grounded in hard chemical science.
All right, section 5, salts, beyond the table.
Remember that neutralization reaction we talked about earlier? Acid plus base equals salt? Well, salts are ionic compounds born from that exact reaction, and they make up incredibly useful household and industrial items. Baking soda is a salt used in your kitchen for cooking and is a neutralizing antacid. Bleaching powder is another heavy-duty salt, and it's utilized globally for things like environmental water testing, disinfecting our water supplies, and sustainable manufacturing practices in the textile industry. Zooming out to a massive industrial scale, washing soda is just an absolute powerhouse of a salt. It serves as a foundational manufacturing ingredient. Without this complex salt, we quite literally wouldn't have the commercial glass in our windows, the soap at our sinks, or even the paper in our notebooks. And I mean, if you or a friend have ever had a broken arm, you've relied on plaster of Paris. This is a specialized, hydrated salt that hardens rapidly, making it absolutely perfect for the medical field to support fractured bones, as well as for artists who are crafting decorative models and toys. Salts literally help build and repair our physical world. Let's bring it home with Section 6, exam prep and flashcards. Let's do a quick knowledge check. Think back to our reactions lab earlier in this explainer. Test yourself right now. Can you identify the specific gas that's released when an acid meets a metal carbonate, and how do we visually prove it? If you said carbon dioxide is the gas, and turning lime water milky is the visual test, you are spot on and 100% ready for that exam question. Take a mental screenshot of these core revision rules right here. This distills all the foundational aqueous chemistry you need to memorize. Acids are sour with H+ ions and a low pH. Bases are bitter with OH- ions and a high pH. They neutralize each other to form salts and water, and they flip litmus paper in opposite directions. Master these traits, and you have mastered the basics. So as you wrap up your studying today, I want you to look around your house and ask yourself, where else are these fundamental chemical reactions hiding in plain sight? From the baking soda causing your cakes to rise in the oven to the soap cleaning your hands at the sink, chemistry isn't just trapped in a textbook. It's the invisible engine running your everyday life. Stay curious, keep observing, and I will see you in our next explainer.